Good day, everyone. So now let's proceed to the alkaline earth metals reaction with water and dilute hydrochloric acid. By the way, our topic for today is focusing on the group 2 elements in the periodic table, which is the magnesium, calcium, strontium, and barium. But before we proceed, let me introduce to you my group members. By the way, my name is Janica Rosayalo, Berdos Fermalin, Nali Grizel, Juhuri Eliza, and Ano Ayesa. We are the group 4. As you can see here in screen, we have magnesium, calcium, strontium, and barium. These four elements is the alkaline earth metals located in the group 2 that share similar chemical properties. Try to look at your periodic table and see the group 2. I know nagawonder mo why beryllium and radium is not included in this. It because beryllium is less metallic and it does not react easily with water and acids, which means it does not show the usual properties of group 2 metals. While radium naman is highly radioactive and it's very unstable and it's rarely found and it's too dangerous to use in the experiments. That's why beryllium and radium is not included in this or excluded in this. It because they have a special characteristic that make them different. The objectives in this topic is to investigate and analyze the reactivity trends of the alkaline earth metals when exposed to water and dilute hydrochloric acid, and examining the patterns in the reactivity down to the group. Reaction with water. We have magnesium on the left side and the calcium on the right side. Try to look at the picture. We have a magnesium metal placed in the cold water. And as we observe, it reacts very slowly with the cold water. But when we put the magnesium with the steam, it becomes active and it forms magnesium oxide. On the other hand naman, in the right side, we have calcium. As we can see and observe sa image, calcium is being placed in the cold water which reacts moderately. Unlike sa magnesium, slowly lang siya. Pero sa calcium, moderate lang iyang reaction in the cold water. And also, as we can see in the image, naa siya bubbles formation, which naka-indicate siya nga gas is being released. And also, nakita po nato nga naa siya cloudy solution. Kay because the reaction makes heat that form cloudy solution na ato ang ginatawag na calcium hydroxide.
Hello, welcome.
So now let's proceed to the reaction with water of strontium and barium. Try to look at and observe the image of the strontium and barium. For strontium naman, as we can see in the image and observe that there is many bubbles and ang solution niya is cloudy na siya, which means that hydrogen gas was quickly released. And ang heat nga iyang ginaproduce is nag-form siya og strontium hydroxide. And on the right side naman rather, there is a barium. As we can see in the image that The reaction was even more vigorous than strontium. And nakita sa nato sa image nga daghan kaayo siyag bubbles and daghan kayo og heat. Show that barium is more reactive than strontium. And also, nakita po nato sa image sa barium nga ang solution niya is nag-turn na siya into milky, proving that barium hydroxide was formed. And addition for that, both strontium and barium react very fast with water, and the reactivity increases as we go down to the group 2 in the periodic table. So now let's proceed to the reaction with dilute hydrochloric acid. We have magnesium and calcium. Magnesium plus 2 hydrochloric acid, it will lead us to magnesium chloride plus hydrogen gas. As we observe in the image, magnesium reacts steadily with dilute hydrochloric acid, and there is a consistent bubbling and formation of colorless solution. While calcium naman is calcium plus 2 hydrochloric acid will lead us to calcium chloride plus hydrogen gas. As we observe in the image, the calcium reacts rapidly with dilute hydrochloric acid. And also naa siya'y vigorous bubbling and noticeable temperature increases. So now let's proceed to strontium. Strontium plus 2 hydrochloric acid will lead us to strontium chloride plus hydrogen gas. Strontium reacts very rapidly with dilute hydrochloric acid. As we observe in the image, there is an intense bubbling and significant heat evolution. And the other hand naman is we have barium. Barium plus 2 hydrochloric acid will lead us to barium chloride plus hydrogen gas. Barium reacts extremely rapidly with dilute hydrochloric acid. And as we observe in the image, naa siya violent, bubbling, and substantial heat released. As we conduct this research experiment, we have some key observation. For gas evolution naman, we notice that all reaction produce hydrogen gas. This is because when metals like magnesium, calcium, strontium, and barium reacts with hydrochloric acid, the hydrogen gas is released as a product. And also, we observe the intensity of bubbling increases as we move down to the group from magnesium down to the barium. And also, for the temperature change naman, we notice that all reactions were exothermic, meaning they release heat. When we touch the sides of the test tube, we could feel that they become hotter, especially in the strontium and barium experiment. The heat releases increase down the group, which supports the idea that the reactivity of group 2 metals increases as we go down to the periodic table. For reaction rate, as we observe, the speed of reaction increases as we go down to the group. For magnesium, the slowest, down to the barium, the very fast. This means that the metals become more reactive down to the group because their outer electrons are easier to remove. For the flame colors naman, each metal produces a distinct color when burned. For example, for magnesium, it produces bright white, calcium orange red, strontium crimson red, and barium produces green colors. These flame colors are due to the energy released by the excited of the electrons when the metal ions are being heated. So now let's proceed to the classification of reaction based on our research experiment. All observed reaction are redox reaction, where the metal is oxidized and hydrogen is reduced. Because when we say redox reaction, it is there is a transfer of electrons between the two substances. Try to look at the left side, oxidation half reaction, when metals lead us to metal plus two negative electrons. As you can see, the metal is oxidized at it forms to the positive ion, which is shown in the oxidation half reaction. Meanwhile, the reduction half reaction is the two hydrogen ions plus two negative electrons will lead us to hydrogen gas because hydrogen ions are reduced as they gain electrons and form hydrogen gas. Another type of chemical reaction under the classification of reaction is a single displacement reaction. When a metal displaces hydrogen from water or acid, demonstrating the relative reactivity of group 2 metals compared to hydrogen. This happens because metals in group 2 like magnesium and calcium are more reactive than hydrogen. For example na lamang, when a metal reacts with an acid, it replaces the hydrogen and it forms a metal salt and the hydrogen gas is released. This demonstrates the reactivity of group 2 metals compared to the hydrogen because the more reactive the metal, the faster the reaction. In short, ang single displacement reaction manggod is ginishow niya sa ato how stronger element pushes out a weaker one from a compound, proving which element is more active or reactive. For periodic trend analysis, as we move down to the group 2, the atomic radius increases. Atomic radius increases due to the additional electron shells. This makes the outer electrons further from the nucleus. And also, lower ionization energy naman down to the group means less energy is required to remove outer electrons, making metals more reactive. And when the electronegativity naman decreases, it reduces attraction for electrons, makes it easier for the atoms to lose electrons and form cations. And when the reactivity increases naman, the combined effect of magnesium, calcium, strontium, and barium, larger atoms with a weaker nuclear attraction lose electrons more readily. As you can see here in screen, we have the reactivity trend summary. From the least reactive down to the most reactive. Diba we have four elements that belong to group 2 alkaline earth metals. We have magnesium, calcium, strontium, and barium. The magnesium is the less reactive. And the calcium naman is moderate. Ang strontium naman is highly reactive. And ang last is the barium, the most reactive, due to the decreasing of ionization. Overall conclusion of this topic is that alkaline earth metals react with both water and dilute hydrochloric acids to produce hydrogen gas and metal hydroxides or salts. And what I've stated earlier that reactivity clearly increases down to group 2 from magnesium down to barium as demonstrated by reaction vigor and rate. And also, this trend correlates with atomic structure, increased atomic radius, and decreased ionization energy to facilitate electron loss. And also, all reactions are redox reaction, where metals are oxidized from 0 to positive 2 oxidation state, and hydrogen is reduced. And lastly, understanding these trends is essential for predicting chemical behavior of group 2 alkaline earth metals elements in various applications. And additionally, I know nagawonder mo why beryllium and radium isn't here pero located gihapon siya sa group 2 in the periodic table. It because beryllium is less metallic and it forms covalent that makes different from a usual group 2 alkaline earth metal that shares similar chemical properties. And also radium naman is highly radioactive and very unstable and is rarely found and it's too dangerous to use in the experiments. That's why both beryllium and radium is excluded in this. It because both of them have special characteristics that make them different, unlike sa four elements that belongs to group 2 alkaline earth metals. And I hope nakasabot mo unsa ko ang ginapoint. And thank you guys for listening. I hope tama ang akong pag-explain and I hope namin nasabtan sa mo ang PPT. And thank you.